Hey everybody, it's Tony from Adafruit, and I wanted to do a stream on an interesting piece of Raspberry Pi software that I saw recently, and it's called PiShift, and it's kind of like a little maybe alpha beta version of a program that turns a Raspberry Pi Zero into a little gadget that you can just drag code over to, so it looks like a USB drive, and you can drag like a Python script onto it, and then it'll just run that Python script. So it's a lot easier for maybe like a newcomer to use, so that you just connect the Raspberry Pi, drag some code over to it, it'll start running it. You don't need to know about like how to SSH into the Raspberry Pi, how to maybe set up like a file system sync to copy code over. So that's kind of the dream. And then maybe we'll just kind of see what the current status of the project is, just play with it, set it up, see how it works. I think you'll see that it's maybe not super easy for beginners to use right now, but it's still worth checking out. I think it's pretty promising as far as what they might do in the future with it. It seems like a really cool idea that I'd like to see maybe expanded and used more frequently with the Pi. So let's just kind of get started. We'll dive into the main view here. Let's go to this view. And so you'll see a few things. So up in the upper right corner, I have little Raspberry Pi Zero. They're so small, it's kind of covered up by the little Pi Cobbler dongle. But basically, it's connected with the Pi Cobbler to a breadboard, and I have a little LED and then a push button over here. These were actually left over from the previous live stream, but we'll see we can use the LED when we run some Python code to light it up. And it's got a couple things else connected to it. So I have, through its USB connection here, this little nifty little hub that we sell in the shop. And so this is a USB hub, and it has an Ethernet jack, so super important to have that, because you'll see to set up this software you need to have your Pi connected to the internet. So you have to do some firmware updates to actually download a new kernel to set it up as a USB gadget. So you'll need something like this. You could plug in like a Wi-Fi dongle, and I'm actually using, so you'll need a little USB OTG adapter to plug in any normal USB devices. So you could use like Wi-Fi, you could use a little wired network adapter. This little hub is kind of handy to have. And I'll put a link in the description below to all the different things I mentioned, like the hub here and a few other things. Now, in addition to this, I also have, and you can't really see it, I have the Pi, the serial cable connected to this. So this is a little USB to serial cable that we sell, and I'll put a link in the shop in the description below. It's a PL2302 chipset, real nice, easy to use. It's connected to the RX and the TX pins on the Pi Cobbler here. That's just the serial port, so you can talk to the Raspberry Pi kernel. And you'll need this because the way this works is on the Raspberry Pi Zero, you can set up its USB port, the normally that you'd plug a device into using this OTG adapter. You can actually set it up to act as a USB device. And Lady Ada actually did some live streams early on when the Pi Zero first kind of came out to show off some of the interesting functionality that you can do with that. So like you can turn it into an Ethernet adapter and then plug, you connect it into your computer, and then it shows up like another network device, and you can kind of SSH into it or talk to different things. That's how like the BeagleBone Black, if you've ever used that board, you basically just plug its USB port into your computer, little micro USB jack that it has, and it just shows up as a network device. You can connect to it. So, you can actually do that. Now, you might be wondering, can I do this with other versions of the Raspberry Pi? Can I take like my Pi 3 and set this up? And unfortunately, no, you can't. You can only do this on the Raspberry Pi Zero and the Model A, I believe, or A+. Basically, any of the models that don't have a USB hub built into them. So if they have like 4 USB ports on the board, it's not going to work, because the way this works is that this little USB connection that we're connected to is directly connected to the processor on the Raspberry Pi, for the Zero model at least, and the Model A. But on the later ones, on like the Pi 3, there's actually a chip that's a USB hub and network adapter that your USB ports connect to, and then that chip connects directly to the Pi CPU. So the Pi CPU can't like switch into a different mode to say, okay, now I'm a USB device, unfortunately, with those. So for now it's Zero only, but that's kind of cool in that, the Zero is such a small little board here. It would be really neat if like you just have this cable, plug it into your computer, and just drag files over to start programming it. So that's kind of the dream, and we'll see kind of what you can do right now with this software. So I'll put a link down. Right now, PiShift is basically just some Python code in a GitHub repository, and it talks about how to install it down here. And so we'll go through these steps real quick. And it's, after I've run through the setup and kind of used it a little bit, you'll see there are a few little bugs and issues with it. So, I'd still kind of consider this kind of beta. I mean, it just came out, I think, a few months ago. So it's, it's not maybe turnkey and that a brand new Pi user could just pick this up and go with it. But I think give it some time, and maybe over time we might see that, it gets a little bit easier to set up and install, and it could be pretty cool. So, okay, and again, I'll put a link in the description to this GitHub repository so you can check it out. But let's just dive in. I've got my Pi. It's running the latest version of Raspbian Jessie, and you need to use the full Jessie image, not the light image right now. Or at least it mentions it. I'm not sure exactly why. Maybe for the Pi kernel that you'll update to, it needs it. But for now, I'm using the Jessie, the full image on here. And okay, so I've also connected my Raspberry Pi through SSH right here. So again, that's just using the little network adapter that I've got connected to, because it does have to have internet access to download the kernel that it's going to use. So to start with, it kind of mentions you have to set up your Pi 0 following this guide right here. And if we go to this guide, at the top, this guide is all about how to set up the 0 as a USB device. So really handy kind of guide. And in the early days, like I mentioned, when Lady Ada first did this months ago, you had to actually compile your own kernel and to add the extra drivers that it needed. Now, luckily, if you read this page, it mentions the Raspberry Pi Foundation actually has a pre-compiled kernel that's ready to go with all of these different USB device drivers. But you do have to switch over to a new kernel, like an experimental or a testing kernel on the Raspberry Pi. And so they mention how to do that in these steps right here. So you start with a full Jessie image, which I've already done. You boot it up and you resize it using the raspi config command. So just standard practice, which I've already done on this card just to save some time. And then you actually run this command right here, sudo branch equals next RPI update. So this is going to run the RPI update command, but it's also going to set this branch environment variable equal to next. And that's kind of the magic that tells the RPI update command that you want to switch to the experimental kernel, or the kind of in development or in testing kernel. And so it's using a later version of the Linux kernel. There's more stuff kind of compiled into it. And so you just want to go into your Pi, and after you've resized it, run that sudo branch equals next RPI update command. Now, I'm not going to run it right now. I've actually already run it on this Pi because it takes about 5-10 minutes. It's going to download a new kernel and load that kernel up on your Pi, and then you just want to reboot the Pi. So, right now I've rebooted, and I think if we check, yeah, you can see my Pi is running the 4.4.6 kernel, which is a pretty recent Linux kernel. I think they're up to 5.0 now, maybe. So it's pretty close to bleeding edge Linux kernel. But okay, so after we do that, then we need to do a few little things right here. So they have you echo this dt overlay equals dwc2 into your boot config.txt file. Basically, this is just enabling a special device tree overlay. So there's a new dwc2 device tree overlay that we need to enable. So let's just run this command as they have it. So we'll echo dt overlay equals dwc2, and they're using the t command to copy this into the file. So /boot /config.txt. So that copies it in, and if we just cat out the file, we should see at the end this dt overlay line. So yeah, there it is, dt overlay equals dwc2. Okay, so that's one thing we have to do. And then the other is we echo dwc2 into the etc modules folder, or file. This basically tells the Pi to load this dwc2 kernel module on boot. So let's echo dwc2 and sudo t into etc modules. So okay, cool, that's in there. And then it kind of mentions now you need to do something based on what kernel module you want to load. And we actually are going to use the gmass storage driver, because this is the driver that turns the Raspberry Pi into a USB device. And there's a little bit of setup that you need to do here, where basically you need to create a file, a .bin file, that will be the file system that this USB drive exposes. So the USB drive won't just expose the Pi's SD card. Maybe there's a way to do that, but I haven't seen any kind of guides that describe it. So basically what this has you do is just create a file on the SD card that's formatted as a FAT32 file system, so like what a USB drive would look like. and then it's going to use that gmass storage driver and say, hey, here's my file on the Pi, make this look like a USB drive. So that's what we want to do. Now you do have to be careful, so this is where you kind of have to stop following the script that they have on this page here, because it tells you, okay, just go down and follow the steps for the gmass storage driver. But if you go back to the PiShift instructions here, it kind of says, okay, follow Andrew's guide up to the point where you start using the gmass storage driver, and then it tells you to make two images, one image called piusb.bin and another called output.usb.bin. And I don't think the output one is used yet, but I think in the future they'll probably take the output of your Python script and write like a file to that output directory so that you drag your script over to OneDrive on here, and then it'll run your script. And then I'm guessing, and it's not implemented yet, I didn't see it in their code, but I'm guessing in the future that when your script runs, it'll take the output of it and then dump it to a file that it puts on another USB drive that you can go and read from it. So that's why they kind of tell you, okay, you need to follow the steps to basically create these file system objects. So, and you need to create two of them. So the instructions here say, here's how to create that piusb.bin, and then I also need to create an output.usb.bin file. Now the instructions here, they show you how to use the dd command to do this, but they create a really small file. It's a file that's 512 byte block size, which is the standard for most file systems. And then you create a file with 2,880 blocks. So times 512 bytes, it's like 5 megabytes or so, which is pretty small. Like, you know, you might want to copy a script over that's more than a few megabytes. So I slightly altered this command, and I'll show you how I changed this. Basically, I wanted to make a larger drive. So the way I do that, I'm basically going to run their command here. So let's do sudo dd, and the input equals dev/0. This is basically just writing all null, all 0 bytes to this file, and the if is kind of the input to the dd command, and of is your output, so it just takes whatever's in the input and copies it to the output. And so the output here I want to create is piusb.bin, so we'll say of equals piusb.bin, and then the block size, or I think it's like the byte size or something for dd, we'll keep this the same at 512. Now count, I'm actually going to change this. So in here they show count doing, you know, explicitly how many counts of these 512 byte blocks to create. But let's do a slightly different syntax to the dd command, where we can set count to the total size we want. And let's say we want 50 megabytes, so you can actually do 50 uppercase M. And then you have to do this if flags, or if flag equals count underscore bytes. I think I have the syntax right. We'll see in a second if this works. But basically this tells it to interpret this count parameter not as the number of blocks right here to write, but as a number of bytes that you want to create. So I'm basically saying create a file filled with zeros under the /piusb.bin and make it 50 megabytes in size, or basically 50 megabytes. It's actually a little bit bigger, I think, because I'm using like block sizes of 512. But let's just hit enter. And okay, so I got the wrong operand. So let's look at the man page for dd. And it's, so this kind of explains how all the different parameters to the command work. So the count is correct, but I think I specified the wrong. So okay, so it's not if flag, it's just iflag equals flags. And it actually goes down and explains more what these flags mean. So if I go down to the flags, so you can see here's the count bytes flag. So treat count equals n as a byte count instead of like a block count. So okay, so let's redo the command, and it's not if flag, it's just iflag equals, oops, I just got rid of it. So iflag equals count underscore bytes. So let's run this, and it just takes a little bit of a second here, and it's going to go. And then it basically says, okay, yeah, so it just created a 52 megabyte file that's all full of zeros. So that's cool. And I thought this made a little more sense, because if you're making these USB drive files, you probably want them to be bigger than like 5 megabytes or so. And this lets you more easily specify, like, okay, I want 100 megabytes, or maybe just, 2 megabytes, something like that. Easier, you can just change that count parameter. Now there's one other command I run. It's the mkdosfs command, and I basically pointed to that bin file. That's just going to format it with the DOS file system, like the FAT32 file system. So sudo mkdosfs /piusb.bin, And that goes, and okay, so that file's good. And now if you go back to the instructions, I need to also create a /output usb.bin file, just like I created the PyUSB bin file here, so formatted with the file system again. So I'm just going to run the exact same commands. So sudo dd if equals dev0 of, the output equals, now I want to change this to, let's change this to output usb.bin. My block size is 512, count 50 megabytes, iflags equals count bytes to tell it to interpret it count as the total size. So let's hit enter. We'll do this. And okay, now that's done. And then let's run the make DOS file system and point it at that output usb.bin file. So okay, cool. And if we do LSL on the root, you can see there those two files are right here. So these will basically be files that are on the SD card, but when I connect my USB drive or my USB port to my computer, it'll show two USB drives, each of them 50 megabytes in size. Oops, I accidentally just scrolled up. And that the contents or whatever's inside of those USB drives will actually be stored inside these bin files using that FAT32 file system in here. And you can actually mount this on the Pi and actually look at the file system, and that's what the code for this PiShift will do. So okay, so now at this point it tells you to make a folder called home pi/PiShift and then put the scripts inside of there. So if you clone the repository for this into the root of your Pi, it's going to give you what you need. So I'm in the root, so like cd tilde, that'll take me to the, or not the root, my /home/pi folder, so the home directory for my Pi user. And that's where I want this to be. So then I'll do git clone to use the git source code manager to just download the files. So okay, that pulled down the code. And now it tells you to put PiShift.py inside of that folder and startmod.sh inside that folder. They're both inside of there, so if I go inside the PiShift directory, you can see there both those files are. So there's PiShift.py and startmod.sh. And if you look at those, startmod is basically just a little shell script that runs this it basically runs the mod probe command, which will load a kernel module. And it's loading this GACM-MS module, which I think is a composite USB device. And it's basically telling it, I've got two different files that I want to expose as USB drives. So this PiUSB bin and output USB.bin file. So you could probably tweak this if you wanted to use different files here. But that's all that really does. And then the PiShift.py file, that's actually the Python source code for this program. It will monitor the input file, like the USB drive, and see if a Python file has been created there or modified, and then it'll go and run that file whenever it sees a change to it. And then it also includes a couple systemd services, so PiShift.service and startotg.service. And the instructions here tell you, okay, after you've got the scripts in the directory, move the two .service files to your etc systemd system directory. So this is how you can tell systemd to run these service files. And this is where I started to run into a problem. It looks like the code in the repository right now has a little bit of a bug in it, where if you follow these instructions, the startotg.service is actually referencing the wrong path. So if we look at this file, startotg.service, this is a systemd service file, and they're actually pretty easy to read and see. So the first part just kind of describes this, this is the kernel module for USB on the go. And it tells, okay, this is when it can run. It's after another service runs. But here in this service block, this is actually what this systemd service is going to run. And this exec start command is saying, run the home pi programs startmod.sh file. The problem is the instructions here told you to create a folder called home pi PiShift and put your startmod.sh into there. So if you use this service file as is, unfortunately it's not going to work. So it's going to run and you won't really see anything wrong. It's just your Pi won't show up as a USB drive. And if you dig in and you look at the output of the systemd service, you'll see it fails with this 200 status code, like it failed to change directories. And that's basically because this path is wrong. So the path, you want to go in and change this to PiShift. So home/pi/PiShift, to the exact location of this startmod.sh. And then also change the working directory down here, because you want to make sure that, oops, it's the PiShift folder again, so that it's in the right directory here. So a little bit of thing that tripped you up. I put a bug on it in the repository, so I'm sure they'll probably fix that in the future. So if you're looking at this video later, you might just go in and just double check this startotg.service file, and if it still has that /programs path, you need to go and change it before you do that. So, and then the other file is actually okay. If you look at the PiShift.service file, this one's fine. So the exec start references home PiShift. It's that PiShift.py file basically. So it's just going to run that Python file, and the working directory is good there too. So nothing to change there. Now, okay, so to copy these into my etc systemd location, so I just want to do sudo cp copy star.service and just copy the two service files into etc systemd/system directory. And if I list everything in that directory, then we should see those files. Let's see. And there's a lot of stuff in here, but you know, these are basically whenever you have a service that runs, it drops a little .service file in here, and then systemd can use it. So you can see there's the PiShift.service and our startotg service. Now the cool thing is, so these services aren't really enabled yet. When a service is enabled, it actually creates like these symlinks to different locations. And so to enable these, they tell you what to do. You run the system ctl command enable for both the service files that we created there. So let's do sudo systemctl enable PiShift.service, and you have to get the case correct, so it's uppercase S in there, and that's going to create the symlink and do the exact same thing. Sudo systemctl enable startotg.service. So run that, and then let's just check. I'm going to look at the directory again. So it didn't really change much, but it kind of told you that it created these symlinks. So it created a symlink from this etc systemd system local fs target folder into links to our service file here. So that's just something interesting. It's I'm always kind of curious how systemd works, so it's not too crazy. Okay, so at this point we're pretty close to starting. So you know, I've loaded up the code. I've slightly tweaked it to fix a little issue. I've enabled the systemd services. They're not turned on yet, and way back I've done a bunch of live streams where I've used systemd. The status command, so run systemctl status and then the name of a service file, so like PiShift.service, and this will tell you that it's loaded, so it knows that this thing, like, it's going to run, it's enabled, so next time I boot it's going to try and run this, but it's not actually running yet, it's inactive. And now I need to be careful, because when I reboot my Pi, it's going to try and use the USB port. It's going to make the Pi look like a USB device, so I can't plug this hub in anymore, and I can't unfortunately use my network connection, or if I had like a little Wi-Fi board connected to this, I can't use this USB port to connect to a USB host or a USB device anymore, because the Pi itself is now trying to act like a USB device, and you can't do both at the same time over the same USB port, like have both USB devices connected to it and let it connect to your computer and look like a USB device. So that's, you know, one little minor issue, something to be aware of, that I'm gonna have to unplug this thing before I reboot. And then you might be wondering, like, okay, well now what do I do if I need to connect to my Pi to like tell it how to shut down? And that's why I connected the little serial cable here, because I'm going to unplug, you know, I'm going to tell the Pi to shut down. I'll unplug my little hub with my Ethernet connection, and then I'll use my serial connection to connect to the Pi, so that I can just see that everything is running the way that I expect. You know, in theory, maybe once PiShift is more fleshed out and kind of fully featured, hopefully it would get to the point where I just unplug everything and I don't even worry about the serial connection. I just plug it into my computer and then start dragging code over to it and like getting the output of it and stuff like that. So, you know, but for now, you're probably going to need to connect to the Pi and tweak some stuff. So I would highly recommend having a serial connection here, because there's no other way to connect to the Pi Zero once you've turned it into a USB device like that. You've got to use the serial connection there. So, okay, let's run sudo shutdown -h to halt, to power off, and now to say do it now, don't wait. So we'll let this thing turn off, and I think it just spins for a second. With the Pi Zero, you need to watch the little activity LED right here, and when it stops flashing, then basically it's done writing to the card and it's ready to shut down. So like right now it's off and it's not doing anything. So I'm going to pull the power to the Pi, and I'm going to unplug my little hub here. And then what I'm going to do is I'm going to actually plug in, just using a standard, this is a USB micro cable, nothing fancy about it. I'm going to plug one end into the USB port here on the Pi Zero, and then the other end I'm going to plug into my Mac computer that I'm actually doing the stream from. So now in theory, when this boots up, I should see a couple drives connected to my Mac, and we'll take a look at this. So I'm going to, well, it's actually already powered itself up. It's booting right. Okay, so let's start over. Okay, so people watching the video now, you probably see a big cut. The problem, I ran into a little issue when I plugged my Pi in to my Mac computer here. It started powering the Pi, like back powering it through the USB connection. So the Pi started booting, and in that process, it pulls a couple hundred milliamps of current, which is probably more than my little USB hub I had this plugged into can supply. And I also happen to have my microphone connected to that same USB hub, and I think that sudden rush of current like either reset or just stopped the microphone. That's why everyone noticed the audio died for a while. So we restarted the stream. I think everything is back to normal here. So just a word to the wise, be careful. Power your Pi first and then plug it into your computer so that you don't get any weird issues like that. It could have been worse. Maybe could have fried a device if it pulled way too much current. But it seems like it's okay. So, okay, I think we're back now to where we wanted to be. And I'm going to connect now to my USB device. So and actually I'm just going to unplug it and plug it back in, because now I don't really trust everything else I had connected to that USB hub. So okay, let's look at, now I'm on my Mac right now, and I'm going to connect using that serial cable to my Raspberry Pi Zero, because I just want to connect and just make sure those systemd services are running. So on my Mac, I just want to check and see what the name of my little USB to serial device is, and I'm pretty sure it's this USB serial device here. I'm not sure why I'm getting this USB modem device on here. I don't think I have any other device. Oh, I guess that must be the Pi Zero itself, because they're using that ACM module, which is a composite USB module, and it must be creating a USB serial device too. too. So that's kind of interesting. Maybe there's something to play with in the future with that. Anyways, let's run the screen command. So I'm going to connect to my dev tty.usb serial connection at 11.5200 baud. So this is going to connect over the serial cable to the Raspberry Pi. And when you first connect, you don't see anything, but if you hit enter, then you get the login prompt. And so now it's just like I've SSH'd into the Pi, but there's no network connection. It's only over the little serial connection there. So okay, so that's all looking good. And then let's just double check. Let's run the system Ctl status for my PiShift.service. And so this is looking good. It's basically saying it's loaded, it's active, and it's running. So it's actually running. It's doing what it should be doing. And I don't see any output here, but that's usually normal. If there were like errors, sometimes you might see the error output. And then let's check the other service. So system Ctl status of our startotg.service. And here we see it's loaded and it's inactive, but that's okay because this script isn't meant to run all the time. It just runs once and it's done. And remember, we looked at the code for that. It just runs that mod probe command. And if you're curious, you can actually run the lsmod command, and this will list all of the kernel modules that are loaded right now. And you can actually see here's that gacm ms module that our mod probe command inside of that startmod script runs. And that loads a whole bunch of other stuff like this libcomposite, and then that loads like the USB mass storage, and then it looks like it also loads a USB serial device. That must be why on my Mac I see a USB serial device on here. So okay, now the big test. Let's look at my file system on the Mac here, and let's see what we've got. So if you notice, there are these two no-name drives now, and these are actually those two files that were created on the Raspberry Pi Zero, that PiUSB.bin and output USB.bin. Now, unfortunately, these don't have a name associated with them, so you don't really know which one is which. And the way that this program works, so the idea is that you can just drag a Python script onto one of these files, and it's going to see that Python script and then run it. And then I think in the future, and they haven't implemented it yet, it'll take the output of that and then dump it to a file that's on one of these other drives. But I did notice that one of the drives is read-only, so you can't copy any files to it, and then one of them is read-write, so you can copy files to it. So if you aren't sure which one to drag your file onto, just try it, and only one of them is going to let you write a file to it, and that's the one that should work. Now, the other thing I've noticed too is that, like I said, they don't actually copy any of the output to like a file, so you can't actually see, the output. Like if you just did a simple hello world, like print your hello world output, you won't see any output. Like it's going to run your script, but you won't really know what it did because they haven't. It looks like they haven't implemented any of the output copy stuff. So what I was going to do is let's just copy over a simple little LED blinking script like this one that I have here. And so this is just using the RPI GPIO library, and basically I'm just saying, the set mode is enabling it to use the pin numbering on the Pi cobbler, and then I set up pin 18 as an output, and that just so happens to be the pin that I have connected to this little green LED right here. And the way I have it connected, the longer leg of the LED is connected to pin 18, and then the shorter leg is connected through a 560 ohm resistor down to the Pi ground. And so that resistor just limits the current. You always want to make sure you have a resistor in series with your LED so that you don't pull a lot of current and damage any of the GPIO pins. So okay, so this is going to set up that LED as an output, and then I just loop 10 times, and I just set that LED to a high voltage level, wait half a second, set it to a low voltage level, wait half a second. So just do that 10 times basically to blink the LED. So okay, so let's save that file, and then let's see what happens. Let's copy it over to the file on our Raspberry Pi here. So let me go to the folder that I have this in, and it's this PiShift folder. So okay, and like I said, one of these drives is going to be read-only, and I won't be able to copy the file to. And on the Mac, so it looks like this drive is okay, so it's going to let me copy, but just to show you what happens, if I go to the other drive, this one's read-only, so I can't, it's giving me this X on here that's saying you can't copy anything over. So, if you see that, just you want to use the other drive, and hopefully in the future they would actually maybe give you a name. I guess when I formatted this file system, maybe I have to give it a name, if that's what the USB modules do, or if there's any way to override that, it might be kind of nice. But okay, let's copy over our file and let's see what happens here. So I just copied the test.py, and look at the LED. It's blinking 10 times, hopefully 10 times. We'll see if it's going to run the code here. So this is pretty cool. We'll just let it finish here. So okay, yeah, so it just blinked. It looked like that was probably 10 times. And that's pretty neat. Like, I've connected my Pi just through this USB connection. It shows up as a USB drive on my Mac. I took a Python script and just copied it right over. I think I could probably edit this file from the Pi itself. Let's try it. I haven't tried it here, so I'm going to drag this over to the Atom text editor, and let's maybe let's increase the speed. So we'll say maybe a quarter-second delay, and we'll still keep it at 10 times. Now I'm going to press the Command S to save my file, and let's see if it copies it over, if it picks up that it changed. Yeah, look at that. It's blinking a lot faster. So that's pretty cool. Like, I could just start hacking away on this script right here and, have it run whenever I basically press save. Like, it's ready to go. Now, you might not want that behavior because you might want to, save the file before you're ready to run it. So, just be careful. Like, if you're doing a really complex script and you get kind of halfway through it and you're like, oh, crap, if I save this, it's going to run, but I'm not ready to run yet. So, maybe you do want to drag the files around here and change them. But that's pretty cool. I mean, it seems like it's doing exactly what it's designed to do here. It's running the script when we copy it over. Now, like I said, unfortunately, you don't get any output. And actually, we can just look real quickly at the code for this PiShift.py, and it's really not that complex. It's pretty simple. Let me just close a few things to get these out of the way. So the main kind of program loop is just right here. I mean, the whole program is only about like 50 lines or so. And you can kind of see, so it calls this grab recent to say, okay, what are all the files that are in this /piusb.bin file? And it actually mounts it using the file system so that it can read the DOS file system that's in that .bin file. So it loads it up, and then it just does like, I guess it looks like it does an ls command to say, okay, what are all the files, and then grab the first file, like the most recent one, and then it'll actually copy that file over to the local PiShift folder. It'll run an MD5 hash on it because basically it looks to see, is this file different from the last file I saw with that name? So like, if you're if I'm updating this test.py file, it's going to use that MD5 hash to see, oh, the file changed slightly, so now it's different, and I better run it again. And then you can kind of see when it gets into the main part of the loop here, it's just using the subprocess.popen function, which is how you can tell Python to run another process. And it's just running the Python process with the script that you copied over, and then it's piping out the output. And basically you can just see like it gets the output. But you can kind of see like they haven't actually implemented anything to read the output of this and write it to a file yet. So I'm betting in the future they probably come back and have some concept of taking the output of your script and writing it out there. But it's pretty cool. I mean, it's pretty simple. The other thing to realize is that right now it's hard-coded to use Python 2.0 and not Python 3.0. And actually the script itself looks like it only runs in Python 2 because here's a print statement that wouldn't work in Python 3. But it doesn't look like this is hard to port over to Python 3 in the future. So I think that's it. Unfortunately, had a little bit of a stream issue there. So, but feel free to throw questions in the chat, and we'll go through and see if we can answer them. But yeah, I just wanted to show off this PiShift program. Like I said, it looks like it's still kind of, I would consider this like a beta or an alpha version. Like I mentioned before, there is a bit of an issue right now with the code in the GitHub repository. The start OTG service file, you need to go and change this directory. It's hard-coded to a different path than what the instructions say here. But after you tweak that, then it's pretty much smooth sailing to get it set up. And it really does work. I mean, as you saw, so like, I'll modify this file again. Let's set this to be maybe like a slower blink. Let's say like a 1 second delay in between here. And then when I save this, we should just see, yeah, there we go. The LED just starts blinking, so it's running my script. I think that's really cool. I'd love to see like maybe a future version of Raspbian. It would be really cool, or maybe a special version of Raspbian. Like a Noobs for Programmers or something edition for the Pi Zero, where if you boot it up and maybe it could just be pre-set up to act as a USB device like this, and you just plug it in and go from there and start programming on it. That would be really cool. That would reduce, I think, a lot of the barriers to entry there. So okay, so let's go back to the kind of headshot view here, and then see what questions we have. So, and unfortunately, yeah, like people that are watching this later had a little bit of a stream issue. Like I mentioned, don't plug in the Pi Zero with other USB devices. You might cause some problems with them. But I think we'll be okay here. So let's see. I don't see a lot of questions there. Okay, cool. Yeah, so I don't see any questions. So I think we're all good. I think we'll wrap up the stream then. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can see all kinds of project videos, live stream videos like this that I do. Subscribe to twitch.tv/Adafruit, and you can watch live when I do these videos. And you can see when things fail live, like when I plug in USB devices that take out my microphone. So hey, it's live internet, anything can happen. And then like, comment, subscribe, let us know that these videos are helpful and useful, and we'll keep doing them. I like to do at least 2 videos or 2 live streams a week. So I do a Monday one where I look at little interesting pieces of software like PiShift right here, or other interesting software. And then Friday I like to do more in-depth, kind of detailed, get kind of your hands dirty working on a project. And so this Friday I think I'll be wrapping up. I did the Raspberry Pi Talking to Wi-Fi Things series, where I just kind of showed like some basics of how to start using little Wi-Fi microcontrollers like the ESP8266, or eventually maybe we'll look at other boards like the AT-Wink 1500 or the Wicked board. All these little Wi-Fi microcontrollers, how can they talk to a Raspberry Pi? Like there's no good simple example of I want to have my ESP send some data to a Raspberry Pi. And so that's what I tried to do with this little series of videos. So I've done 3 videos so far, and I'll wrap it up with a 4th one on Friday this week. And I'm thinking maybe we'll play with MQTT in this Friday one. So we'll look at how to run a little MQTT broker on the Raspberry Pi, and then have your Wi-Fi board talk to the Pi and send and receive MQTT messages. So we can look at that and see, compare and contrast that to socket programming like what we did in the last video. What are some advantages, what are some disadvantages to using a protocol like MQTT like that. So that's it. So we'll wrap it up. Thanks a lot for watching, everybody, and I'll see you guys on Friday this week. So this is Tony from Adafruit, and I'll see you guys later.